Okay, in the last video, we introduced the idea of the sigma notation for a sum, and we took the limit of that sigma notation as n went to infinity to get the integral notation. And so what I want to do at this point is I want to show you a couple things that we can do with this. And the first is going to be, how do we go from a sum to an integral, and what are the little different bits. So I'm going to illustrate this through an example. So our example is as follows. We want to take the limit as our number of partitions goes to infinity of the sum from our index k equals 1 to n of the following equation: 3 times m sub k squared minus 2 times m sub k plus 5 delta x. Now remember that m sub k is the middle of each interval. And so we're taking 3 times the middle of each interval squared minus twice the middle of each interval plus 5. That will give us the height of each rectangle, and then delta x, the width of each rectangle. And we're going to look at this on the interval -1 to 3. What happens? Okay, so let's break this down. First of all, the limit of the sum. Well, the limit of the sum is the integral. Second of all, the interval -1 to 3 is our endpoints, our indices. Our function we're going to rewrite this as 3x squared minus 2x plus 5, because this is in fact just a parabola. And finally, delta x, remember when we take the limit as delta x goes to 0, we end up with dx. So there's the four parts. The limit of the sum gives us the integral. The interval -1 to 3 tells us the lower limit and upper limit of our integral. The equation inside telling us the height of each rectangle is our function, 3x squared minus 2x plus 5. And our width, delta x, becomes dx when we take that limit. And how do we interpret this? Well, this is the area. Area. Let's try that again. The area under the curve 3x squared minus 2x plus 5, or technically y equals, in the interval -1 to 3. So there's thing one. That's the first one I wanted to show you. What do I do if I have a summation and I want to go over to integral notation? So let's look at the second example, which is to evaluate a particular integral. So I'm going to look at the integral from -2 to +2 of the square root of 4 minus x squared dx. So again, let's think about what we've got here. I'll try to keep the colors the same. So 3 for the interval, green for the interval, gold for the function. So here we go. We are first of all looking at the interval -2 to 2. We are looking at the function f of x equals the square root of 4 minus x squared. So let's go ahead and analyze this. What do we know about the function square root of 4 minus x squared? Well, I remember this being a semicircle of radius 2. So the question, the integral from -2 to 2 of square root of 4 minus x squared dx is asking me what's the area underneath that semicircle. So I know that the area is equal to pi r squared of a circle, but I've only got a half a circle here, so I'm going to divide it by 2. Radius of 2, the area of this semicircle is 2 pi. Pi times 2 squared divided by 2, which tells me that the integral from -2 to 2 of the square root of 4 minus x squared dx is 2 pi. All right. If you are in my class, why don't you open up your book and do exercises 5 and 15. 5 goes with the first example, 15 goes with the second example, and we will be back with more. Thanks for watching.